All right, so hopefully you've had a chance to try these on your own. Let's take a look at the first one. The first thing we need to do is just find the antiderivative, right? We're just going to take that antiderivative and evaluate it from between 0 and 2. All right, so the antiderivative of 6x squared, 6 is just a constant, so I'm just going to write it down, and then take the antiderivative of x squared. So the antiderivative of x squared is going to be x cubed over 3. All right, and I'm going to evaluate that antiderivative from 0 to 2, which means I'm going to, now let's simplify this a little bit and make this 2x cubed. All right, so then I have 2, and I'm going to take the upper limit of integration first and evaluate it there. So it's going to be 2 cubed, and then minus 2 times the antiderivative evaluated at the lower limit of integration, which is 0. So 0 cubed. All right, that 0 cubed is just 0, so we just have 2 times 2 cubed. 2 cubed is 8. 2 times 8 is 16. So the answer to this first problem is 16. All right. All right, so again, we're just going to find the antiderivative. Antiderivative of t cubed is t to the 4th over 4. All right, we're going to evaluate that from 0 to 2. All right, so I've got to start with the upper limit of integration. So it's 2 to the 4th over 4 minus 0 to the 4th over 4. Of course, 0 to the 4th over 4 is just 0. So we have 2 to the 4th over 4. So that's 16 over 4, which is 4. All right. Okay, so this next one, we want to find the antiderivative of 8x plus 5. Okay, so we've got 8. The antiderivative of x is x squared over 2. And the antiderivative of 5 is going to be 5x. And then I just want to evaluate that between the limits of integration, so from 1 to 2. All right. All right, so let's see. I can cancel a factor of 2 here. This becomes 4x squared. So I'm going to take 4 times the upper limit of integration. I'm going to evaluate the antiderivative at the upper limit of integration first. So 4 times 2x squared plus 5 times 2. Okay, that's evaluated at the upper limit of integration. Now we're going to evaluate at the lower limit of integration. So we have 4 times 1 squared plus 5 times 1. Okay. All right, so what is that? So we have 2 squared is 4 times 4 is 16. And then plus 10. And then minus all of this. So that's going to be a minus 4 minus 5. So that looks like it's going to come out to be 17. So my answer is 17 for that one. Okay, so one more here. We just need to find the antiderivative of 8e to the 2t. So 8 is just a constant. I'm going to write it down. Then we have 1 over, this is like our k value, so it's going to be times 1 over 2 e to the 2t. Okay, that's the antiderivative, and then we're going to evaluate it from 0 to 1. All right, so now again I can simplify this a little bit and make this, basically it becomes 4 e to the 2t, right? So I get 4 e to the 2 times 1, because I'm going to evaluate it at the upper limit of integration first. So this becomes 4e squared minus 4, well, basically evaluating this at the lower limit of integration, I get 4e to the 0. E to the 0 is 1, so I have 4e squared minus 4. Now, this asks for, let's see, a lot of times I ask for exact answers. Now, this would be the exact answer. This particular problem doesn't specify whether you need exact answers or not. So we could put this into your calculator, and we get 20 5.56, which is also what your calculator would give you if you evaluate this definite integral on your calculator. Okay. Now I know you can do this on your calculator and you don't even have to find antiderivatives. But in some cases where you're asked to find exact answers, your calculator can only do the integrals numerically, and in order to find the exact answers, then you have to actually evaluate the integral, the definite integral using antiderivatives. All right, so I've got another example, and I'll meet you in the next video.